Welcome, Internet World. Welcome to the RC Air Experience, episode 34. It's a good one. They're all good, but this one's a great one. We've got some famous people here with us, Joel and Melanie Vlashof. Did I get it?
Yes, you pronounced it pretty well. Yes.
Awesome. If you guys are on YouTube, Facebook, all the different channels, you will have seen the stuff that these guys do. I know you guys have been working on a vertical takeoff and landing aircraft for quite some time. Exactly. And thank you so much for joining us on the podcast. It's great to have you guys.
Well, it's an honor to be here on the show. Thank you for having us.
Thank you. So tell us where you guys are located. Tell us kind of, how long you've been in the RC world, the hobby.
I'm sitting here with my wife, Melanie, and the truth is already that she owns the YouTube channel. So that's the kind of secret that I want to say. So we started, let's say, 50 years ago when we were at a grass airfield located in the Netherlands, where I destroyed all my landing gears. So at some point I said, oh, come on, guys, there's an F-35 coming up. The Harrier is there. So why not making an airplane that goes vertical? And everybody was laughing, and I started with my first motors, and the KK2 board came on, some starting point of flight controllers. And so we were starting to play with this kind of stuff, and somehow we managed to hover something in the air. Nice. So this is actually how it started. And the passion for vertical takeoff. And we had this dream, and also, you were very supportive when we hadn't had kids before. But still is. But so if you want to ask how the YouTube channel started, well, actually by accident. So when we had our first hover platforms, let's say, we were actually new into this with PID settings, how to tune the motors to keep it level and auto level. And we were actually pretty scared at the time that it might fall down because, I don't know how it works. So at some point, Melanie was filming all the videos from the side. So if you go to the oldest video, oh my God, no. So the oldest, Oh, there you go. So these were actually our first videos. Wow. And Melanie was always filming from the side, right?
Yeah.
And also from the front. And we used to store it on the iPhone. But we had a lot of memory back then. So we stored it on YouTube. And at some point, we got a letter, right?
Yeah.
We got a letter from Google from, is it okay to, you got 500,000 views. And I said, whoa, is this a lot? And it's actually how it started.
Wow.
Very
cool. I remember watching those older videos with the airframe you started off with. And it was basically like sticks, like glued together, holding the motors and stuff together. It's wild how far you've come. And I remember, like, when I first stumbled, I've been following you probably not 12 years. I'd probably say I've been following you for probably 8 years, 9 years, somewhere around there. Because I came from the drone world and as well. So there's some crossover with the flight controllers and stuff. And I remember seeing the first time you did the assembly at the first video I watched where you did the assembly for the F-35 where the thing was twisting and turning down. I'm like, holy cow. Like, how much time and work did that take? That's the most amazing part of it to me, is what you were able to figure out with the gears on the top. That's just, it's crazy. It really is.
So first of all, the cool thing about our YouTube community, there are lots of brilliant minds out there. And I could have done it without the guys out there on social media. And one of them is also Eric Maglio. We are now knowing each other for almost 10 years also, but also the good friends who are supporting us. And we're sharing this passion. And if you share passion and people get excited, and they're going to help. And in a couple of minutes, I want to invite Ingmar as well, and later on also Siggi, who have been a great help. So as background, I'm a mechanical engineer. Yeah, this is where the gearing part came from. But I'm not an electronic guy, and yeah, later on, Ingmar can tell his story about how we did with our first, or what was it, from Polo Lou. We had this gear motors with this counter on it, and I didn't know anything about Arduino and how to program this together. And at some point, yeah, we made it, but we made about like 100 of iterations to make something. Do I have one somewhere in? Oh, that one. Can you give it? Sorry.
It's okay. No, it's awesome. Take your time.
So this took like 100 iterations, let's say.
Wow.
I'm sure. Hold on a second. Let me stop presenting the screen real quick so everybody can kind of see it. There you go.
Wild.
So this works. So we're using 2 CAN servos, but we will start the story from the beginning. So this is eventually how it turned out with the CAN system from Erik Maglio. That guy did also a brilliant job with the electronic part, but we started more hard, let's say.
Yeah, I'll share Eric's screen real quick so anybody who doesn't know can then just look it up real quick and see him. Hold on. I'm going to stop that one. I'm going to share screen.
So Joel, your first iterations of that piece, were they done 3D printed as well too, or are you making them out of raw materials?
Well, the first were, I got my, yeah. The first was a really old first 3D printer. It wasn't really nice, but even I thought it was aluminium back then. Yeah. It was aluminium banded with servos inside that we connected to each other, and they turn like 180 degree, but it wasn't actually. Oh yeah, indeed, with the cable. So we used, the secret is that we are using a fishing line to connect these 2 parts with each other, and they work independently. See?
Cool.
That's wild. That is so wild.
Wow.
And so this is actually a 90 millimeter version. We got also a 150 millimeter version, and the biggest that we tried was 130. Yeah.
See, I'm amazed that, I know it flies, but the weight that unit adds, plus the weight of the 3D printed planes, it's amazing. It's amazing that it flies, and it flies good.
So thank you. So we are. So this is where this is the topic where Siggi came in. So we designed our own concept of vertical takeoff. What we think, honestly, we are not aerospace engineers. Right. We are doing this by iteration, trying to reach our goal as efficiently as possible. If you look at all the EDS that we used in the past, this is more than 50, a lot of EDFs. Some burned, some got hot, some didn't give the pressure. The setup what was put it on the label wasn't there. So it was a lot of iteration, LiPo testing, ESC testing, and these days we are living in 2025. If we got the technology from today back then in 2015, we managed already way more sooner. But this learns us the hard way to make it perfect, because it's this super difficult. Can you imagine that you are lifting a 10-kilo model?
Yeah.
But you need, in our case, with a 10-kilo model, you need like 20 kilos of thrust,
right,
to escape ground effect.
Yeah.
But if you are lifting a 10-kilo model, some say, okay, with 12 kilos you are enough, but you want to relax the setup by 50% to gain flight time and time to be in the air. So this is where also Siggi will came in with the story. But before we go to that, I want to give the floor also to Ingmar, who can tell you more about the story. And
before you go that route, I'm thinking about, you probably started out with like an Ender 3 3D printer, right? Like what was your first printer?
Even older, yeah.
Even older, right. So thinking now, right, when you were talking about how much better the printing and the technology has gotten, now I'm thinking about it, and you did all those iterations, and John, I don't know, did you ever have one of those older, you never had an older Ender 3 printer, right?
No. I mean, I only started a couple years ago.
So think double to triple the print time.
Yeah.
So think about that. To today's standards, you're talking, they maxed out at 50, 60 millimeters a second. That was max on some of those first printers. So the amount of time that he's waiting for this thing to print on these parts just to go up, this part isn't working, and then swap it, redesign it, and like we're talking days, hours, of
day
just
after
printing.
day after day. Yeah,
right.
And
That's
to give
the
you
part
guys a small secret,
yeah.
and I really love my wife, but we put an alarm like 3 o'clock in the night to swap prints.
Yep.
Oh wow.
And she also helped me a lot. So thank you so much, Melanie, for all those supporting nights that we are swapping parts, iterating, filming, and do the thing. But this is more than passion. What made this driven, right?
Yeah.
And this is the start. That's the beginning of the story that we want to share with you. This is driven by passion. It's almost like a lifestyle. If people are now talking about Joel, he's always on. He never sleeps.
Mhm.
How does he do it?
I say that about
And my friends sitting next to me. Hey,
I say that about John. John's like my hero too. He's always posting, always building, always doing something. I'm like, how does he do it? Like, how? I don't get it.
you should have a supporting wife as well.
You
And you
very
got
much
kids,
so.
right?
Absolutely.
We both, me and John, will say that we have supporting wives.
Very much so. Yeah.
To do what any of us are doing, you have to. It's not possible. So, Melanie, thank you, because your support gave the community something really great. I mean, it's
Thank you.
that F-35 really is the standard for, homemade VTOL F-35s. I don't think, you're
She's happy because when I take off the F-35 in the living room, I open the windows, I open the doors, and all the dust is vanished. I should get sponsored by Dyson, let's say. And she comes home and the house is super clean. Even the cat's blowing away,
So before we hop to your guest, also one more quick thing, and I don't want you to necessarily bash anybody or anything, but you said that you came across a whole bunch of EDFs and you went through the whole thing. What is your preferred brand now? Like, since you've gone through all of them, who do you like now the most to use for your projects?
Well, there are also a couple of other new brands which I do respect because I respect all EDFs in the world.
Right.
And also the Chinese brand I do respect. And I always tell to my followers, you buy an EDF according to your needs, right?
Yeah.
So if you buy a 64 from Freewing or a 70 from JP, or you got the money, you buy a really big Schubler for a couple of €1,000. If it works for you, it works. According to Vito, and I think Siggi will also help me with this question. In our case, we need lightweight, we need pressure, we need efficiency, and this is what works for vertical takeoff. So my preferred brand at this moment is JP.
Okay.
Why? Because if you look at, I got one over here, I guess. So this is a 70. So this is a 70 millimeter JP. And for me, it's really, you got a lot of blades. It's lightweight, only 200 grams. You can push this EDF, this small, tiny EDF, to 7S.
Wow.
And this can push between 3.5 and almost 4 kilo on the static bench.
Wow.
So crazy, huh?
Yeah, I didn't know it would do 7S. That's pretty impressive that it'll do 7S.
And what they're super impressive. They go vertical. And if you look at the blades and also the stator, it's fixed, right?
Yep.
Yeah.
So you got a lot of efficiency to the engine. So this is not for that they sponsor. I need to buy this, but these are really lightweight, powerful EDF. So the only disadvantage about JP is they go to a maximum size of 120 millimeter EDF. Okay. So if we go to bigger EDFs, I would go to maybe Fussy Fan or Tom E from E-Jets or Schubler.
Yeah. Mm-hmm. I'm surprised that you say that JP is lightweight compared to one of the carbon fiber EDFs, because that's aluminum. I'm surprised that that's the one.
This is just 200 grams.
Wow.
Yeah.
No, I've heard great things about the JP EDFs. So, and they are affordable, let's say, compared to some of the more expensive ones. So you do get a lot of bang for the buck out of the JP EDF.
Yeah.
So that's a good choice.
But to be honest, I respect also the 70 millimeters from Freewing. Motion RC. I'm a big fan of Motion RC as well. Yep. But they got you need to use them for different purpose.
Right.
Right.
Right. You're looking for a specific EDF. You need like they make good EDFs, but you need a specific EDF to meet your
exactly.
Right.
And if you want to make vertical takeoff work, if you need to fight for, in the beginning, I needed to fight for each and every gram. And also Ingmar will tell the story in a few minutes. We needed to fight for each and every gram and for efficiency that you got, oh mate. And also and now you got a lots of pressure. And we now find out, so if you got a model of 5 kilos, our static pressure to escape ground effect must be 7.5 kilos to escape ground effect. And then you can relax down and then it can hover and float quite long. But if you're building a model for like 10 kilos, you need 20 kilos of static vertical takeoff because the body, the weight and the mass you need to bring up. And keep in mind, if you are pitching, and this is also what Eric Maglio told us in his, one of his videos, he told we are using pitch differential between the front EDF and the back EDF. So if you are squeezing your EDF to the max, you don't have pitch differential or roll differential. So then you use only 70% of the max capacity for vertical takeoff. So it's really hard. And even for example, the Pegasus ducting, you lose 70. It's only 70% efficient. Wow. So keep in mind that. We're talking about all of losses. So the story is an EDF is not a compressor. It's it's a fan.
Right.
Crazy,
wow.
Yeah?
No, it's the whole thing's crazy. It's that's what I said in the beginning. The weight, the fact that you were able to get it to fly, because that assembly, right? You got the 3D printed gears and that assembly itself, and that assembly is kind of at the back of the plane. So now you have a tail heavy plane right out of the gate, right? Because of this whole assembly. So it's wild.
And can you even imagine? So when your thrust vector are pointing downwards, you need all of those to lift up vertically. But once you go to an outbound transition, the tail EDF pivots, like let's say 45-degree backwards. So your thrust vector lines are 45-degree angled and 90-degree angled. So then it will drop.
Right.
You know, so you need even more powerful EDF in the back to push through the mass. Actually, it's
wow.
Yeah. But we did it last weekend. We did it finally after 7 years. So finally,
7 years.
The full transition. So vertical takeoff, go into flight, go back to vertical, hover, landing. It wasn't not the most beautiful flight, but it's there on the YouTube channel. So this was a moment never to forget. And so we're not.
Congratulations!
Thank you so much.
That's huge. That's huge.
Yeah.
7 years. Holy cow!
Only for the Harrier and for the F-35. 10 years?
Yeah.
More than 10 years.
11 years for the F-35.
Wow.
Only doing the same iteration and after iteration. And that's why our story needed to be changed, because we were, like that you heard, we started with composites because it's lightweight, but it's super expensive to build molds, change the design again.
More
and
time.
This is actually where Siggi came in with 3D printing. We started to print our models before we're going to make molds out of it. So yeah.
So eventually the goal, like once you get everything solved and figured out and everything, then you can make molds out of composites. Is that the goal? Yeah,
that's eventually the goal. So RC jet print. So we make an F-35 1:10 size, which is fully printed, or 1:12 size. And this is our play F-35. It will learn us the thrust factor we need, the thrust differential. We're still using an old computer board, and we need to learn about INAV, the newest, or maybe the PIXOC. We need to swap to that, because I can maybe ask you more about this, Anthony, about the flight controllers these days with the fetal setup, because it's getting more common these days.
Yeah.
So we have our toy ground, and then if it works, we make a bigger one, like the one upstairs here.
So that's the ultimate goal, is you're going to make a kit eventually for sale. This is going to be something that people can buy as a composite. Basically.
First, I'm chasing my dream, to be honest with you. And we both all know our hobby is super, super expensive.
It is.
So it's not only the YouTube part that helps fund our project. You need to Also, our workshop is getting more and more and more, and the parts you learn about the brands you learn from your following community. I met so many beautiful minds in this world, and I tried to visit them all. I went to Valencia, Germany, Spain. I wish to visit Eric in the States. We're going to Switzerland with the virtual meetings, just to visit the few who are sharing the same passion for vertical takeoff. And there are not a lot of people, but the community is growing. And oh, this is awesome. And once you see the story playing on the field, you take it off. Okay, it's a nice printed bird, but it sounds like a turbine. And people is like, what?
Yeah.
This is awesome.
VTOL is becoming more common in the community to the point where INAV did add it. You're still using the KK2? That's what you're using right now?
Yeah, I'm sorry. Yeah.
Oh my God.
Oh, sorry. Yeah, this is the part where Ingmar needs to join us.
Hey, bring him on in. It was very nice meeting you. Thank you for coming on.
Thank you. Bye-bye.
You're welcome. Thank you. It was good meeting you.
Yeah, we're going to talk about.
So Joel,
Yes.
before we dive into the specific, you were also telling me the other day that you have a job too. You have a full-time job too, right? On top of all this.
I'm working full-time at Philips.
So you're doing all of this with the kids, and you have a job. God bless you.
That's good.
I heard it, so I needed to say regards from Felix. I just had a chat 1 hour ago, so I needed to say hi from him.
Oh,
but
okay.
if you look at my, it's really, it's hard. So I have the kids, small kids. You've been there all our journey, Ingmar. Yes, all of those. Yeah, full-time job. But I'm now slowing down, let's say, and I'm happy, and I feel blessed. Also, tonight with you guys, I feel blessed with good friends who are super supportive. I'm so happy, blessed with a wife that's super supportive. Right. So I'm now taking it easy. You need to know when you are happy, but we're not there yet.
Yeah, you're getting there. 11 years in, you're getting there. You're almost there.
I never get bored.
11 years. That's commitment. 11 years is commitment. I'm sorry.
Heck yeah.
And this guy, he's been there the whole journey.
Wow.
Most people would have gave up.
Who is this?
Most people would have gave up. Introduce yourself, buddy. Introduce yourself.
I'm Ingmar Hendricks. I'm a software architect during the day, and sometimes I help Joel at night with his hobby. I've known Joel since I think January 2014.
Yeah.
So more than 11 plus years.
Yeah.
I met him. A neighbor introduced him to me, and he said, "Well, Ingmar, I know that you graduated from university with all these drones things and communication protocols things, and I know this guy who lives in the same neighborhood who's also building things like that." So he introduced us, and I think all the way, almost immediately, we started building stuff
we
together.
were directly on the same wavelength.
Yeah.
So it's easy to tune to each other if you are standing on the wavelength, right?
Yeah. Yeah, and for me, the hobby actually is not necessarily RC airplanes. For me, the hobby is the building, creating complex things and making things work. Like I deal with software during the day, but I really like tinkering with electronics, 3D prints. I really like as well. Of course, not to the same level as Joel, but he's really good at it. But yeah, electronics, software, that's my area of expertise. And when I met Joel, he was still building things, a lot of things with wood. I think from not very long afterwards, we started experimenting with 3D printers.
Yeah.
And eventually we were like, but this is not practical. You know what? I had a little bit of experience with glass fiber and composites, so I basically sacrificed my
living room
to create like a little composite lab, and we created the first F-35 mold.
Well,
I remember I know you're friends with Renee, but I remember there was a period, probably, I don't know, a couple of years ago, where Renee was going through and testing composites with 3D prints and testing different layers of either composite on a 3D print, and not the epoxy, like a layer of epoxy, see how much stronger that would make it. So were you guys a part of that whole testing of the composites and the 3D prints and everything? Because I know Renee went through a period of that as well, where he was testing 3D printing and composites kind of at the same time.
Oh, you mean René Roosentreger?
Yeah.
Ah, René.
Yeah.
Yes, we met each other at the Friedrichshafen back in 2018.
Okay.
He was making the SUX vertical takeoff.
Yep.
Also composite.
Yep.
And that guy is a composite builder and like lightweight.
Yeah.
And,
He's the SU, I think it's a 47. It's a weird plane. But he started with 3D print, right? That started.
He started with 3D printing, yeah, because also for the fast iterations, what you can do first, it was the idea to iterate molds to print them directly negative. We were very inspired by our friend Rami.
Okay.
And he's printing the molds directly negative back in the days before he started at Tyler's place. So we got inspired also by him to print our molds directly negative with our starting with better quality printers like Reality, and slowly with Bambulab. So this was a way to iterate a little bit faster with the prints and the molds, let's say. Yeah. So they needed to help us because
absolutely.
Yeah, the Harrier is really hard to find. There is so much. Again, beautiful minds and passionate guys like all of us. We are all sharing the same vibe for RC, who are trying really hard to build the Harrier, for example. The Harrier has been out there for many years, and people are trying for almost 50 years. And I've met them personally in Friedrichshafen, and some of them they almost I don't want to butcher all the names, but there are so many people like over 30 years trying to make the Harrier work. And I've met them all on the Friedrichshafen. And next year in May, we're going to go back. We're going to show the Harrier and the Dornier. And those guys are in tears. They are loving it. And some of them were even working on the Pegasus engine. And they were old guys, old grandpas. And they were almost crying. And they were like, "Can I touch the nozzle?" I gave them the nozzle, and they were like, "Oh, when we had this back 40 or 50 years ago, back in the 60s, we were being really be the best back then, because they used models as well to test the airplanes." And this is really hardful. So
So you're saying the Harrier is a lot harder than?
Oh my God, yeah.
Why? Is it because of the smaller nozzles instead of the one fan in the middle, or like what's the issue? Why is it so much harder?
Oh, therefore we need Siggi in this show because the Harrier is really hard, because once you find the perfect EDF, right, you're going to divide the airflow into 4 nozzles, like the real Pegasus ducting, right? Okay. So an EDF is not a compressor. So when you start dividing air into corners, you're going to lose efficiency.
Gotcha.
So the efficiency what we have, for example, out of a 130 millimeter EDF is 70%. So you keep in mind. So if you got 10 kilos of thrust, I got 7 kilos of efficiency. And I told you before, a couple of minutes ago, you need 1.5 times the TOA. So if your model is, let's say, 5 kilos, then you need 7.5 kilos to take off to escape ground effects, right? This is, in our opinion, the way to have a relaxed hover situation. But then you don't. So you have nothing left for adding weight to the model. So you need flaps, you need servos, lighting, landing gear.
Yeah.
So how are you going to lift it up? Because I'm short. 10 kilos, 7.5 kilos. I need actually 10 kilos again to gain our climb. So that's why we added a front and a back EDF for pitch differential. Small EDFs in the wingtips. We tried before with pipes to take bleed air from the main EDF, but we found out the mass is getting unstable. So we call it the devil circle, and this is where Siggi can tell you a lot, because we have so many late night talks.
We can try bringing him back on. If he's ready to come back on, we could try it.
He's ready. He's ready.
Yeah.
For everybody in internet world, as John likes to put it, we had Siggi on in the beginning, but then we were having an issue with the StreamYard program that we use, and he decided to hop off for a little bit, but he's patiently waiting in the background.
Yeah.
So we'll
let's
try
try
to
get him back on the show.
Let's see if it works. Let's hope it works this time. We had all kinds of issues in the beginning.
Well, chances are we'll be able to hear them, but you guys there won't be able to hear them. So we'll see.
Right,
But
well,
we are
if we
super
have to-
aligned because we're doing this for many years. We have no
Yeah.
secrets for each other.
Right. So if we have to play telephone, we'll figure it out. We'll play telephone.
Yeah.
Maybe calls, or maybe a short pause.
Hmm.
Let me see. Video.
Yeah. Then we'll talk about the flight controller that you're using. I can't believe you're still using the KK2.
Okay. Yeah. Here he is. So let me show you. Yeah, we can jump into that discussion. It's really interesting because I truly believe if you can build it old-fashioned way, and you trying to build a mechanic plane around it that works, and I truly believe once this setup works, like the Harrier that you just saw flying, once you put a modern flight computer, it works. It's finished directly.
Right.
Because this is the idea. Okay, here we go. Hi, Siggi. Can you try one more time, please, to click on the link?
Yeah, I tried it.
Okay.
Doesn't work.
We're now talking about the Devil Circle. We need you on that for that. Oh, it doesn't work, so I will try to send you a new link, okay? We have the time. It was paused already.
If you want, what's his email? I can send him a link myself.
Can you WhatsApp me your email, please?
Hold
You
on,
will get
hold
a
on.
link in your email.
I'll send it to him.
It's on it.
archichat.de?
Yes.
Oh, okay. I go to.
All right. So his links on his emails on his website. I'll grab
Yes,
it.
info@archichat.de.
Yeah, I got you. I'm going to pull it from his website right now.
You will receive a mail, buddy.
Yes.
You got it?
I got it. I got the email. I'm going to send it over to him right now.
Mag jij trouwens pakken, dat watertje? Top.
Paste. Okay. Podcast link.
Ik heb het verteld.
Okay. And I will send it straight to him, and hopefully that will work.
Oh, the F-25. It's over there somewhere.
Ja, met de Harrier in beeld. Dat is heel mooi.
Oh, you guys are in the background. Can you see it?
Yeah.
Yeah. Oh yeah. There it is. Nice.
Yeah. They sent you an email, Siggi.
Yep. I sent it to him an email.
Yeah, here we go. RC Air Experience podcast.
Yeah.
Link.
That's us.
That's you.
Then let's click on it.
Okay. And then I will go out of this call in a minute.
Ah, here we go. I think I got it.
It should be the same link. I don't know why. Every episode is the same link.
Mm-hmm. So he clicked on it.
So weird.
It is. It's very weird. We've never had this happen before.
Or then he needs to use his phone then, but we got...
Just let him use it.
So, Emar, you do this stuff, you work on drones during the day, or are you just doing software programming?
So during the day, I actually work in the semiconductor industry. To simplify a little bit, what I do is I basically build a machine that on a microscopic scale can make 3D interconnects on a unequal substrate. Basically, to simplify it, a microscopic 3D printer.
Wow.
Yeah.
That's pretty cool. Siggi, can you hear us now?
I can hear you perfectly, yeah.
Yeah.
And the sound is great. Yes, we did it. Good.
We have the technology.
Yes.
So I'm going to share Siggi's website real quick for everybody. And a lot of people have probably seen RC Jet Print. Also, after that, I'll share Joel's website, which is VJM Aviation. They have a website as well, some of the models and stuff. And I will pull up Siggi's. Let me just go to home real quick.
This is fun having 4 people on or 4 screens on 5 people.
Lovely.
Listen, don't start going crazy, all right? We got it this far, okay? Don't get crazy ideas now. Who knows? All right, present, share screen. There we go. All right, so there's RC Jet Print. That's Siggi's website for everybody out there in the internet world. And you basically sell the STLs for the models, right?
Exactly, yeah.
Yeah. Oh, there's the SU-47. We were talking about that before.
Mm-hmm.
Very cool. So this is the internal. This is the internal on the Harrier.
Yes, it is. Yeah, for the 90mm version, exactly. Yeah.
Wow.
It's challenging, as you can see the techniques, right?
Yeah.
Yeah.
I can.
So, like we told before, we got a 70% efficiency out of this ducting unit, which is, I think, the best what you can reach at this moment. We tried many sizes as Siggi, so also 90, 105, 120 millimeter EDF, 130 millimeter EDF. We use different brands, also the expensive EDF like Schubler. And all this comes with a challenge. Also, the other brands that we tried, you think about if you're going to compress air, you get heating.
Right.
Your airflow around the motor is not that efficient anymore. You are hovering quietly in the air, so there is no airstream to cool down your ESC, for example. So also your ESC needs to perform. There you got also the batteries and so on and so on. So everything must work correctly. Even the small servo arms, they cannot fail because it will just crash.
Exactly.
So does it make a difference? So that on the screen, that's 3D printed, obviously.
Yeah.
Does it make a difference if so? With 3D printing, I mean, there's going to be a little bit of micro texture there on the surfaces. Does that micro texture, or that texture on the surface, make a difference as opposed to a smooth surface?
Well, we're not aeronautical engineers, but it might actually help because of the same thing as with a golf ball. You have the little dimples that create turbulence and basically allows the airstream to flow more easily over the surfaces.
Yeah.
So you could argue that maybe it helps, but again, we're not aeronautical engineers, so we just go by trial and error.
Yeah,
But-
and we said
but-
it, and we tried, and
Honestly spoken, it is minimal.
Okay.
It is really minimal. We have tried out ductings that are made out of fiberglass, really smooth surface.
Mm-hmm.
And then compared to a printed ducting, we are talking about 1% limits there. It's not that much. The positive thing or the plus when you are printing it like this is that you save completely weight, right? Because the Harrier topic is a weight issue and a thrust issue, nothing else. This is the project we are dealing with, and when you combine the Pegasus ducting within a complete print that is already within the fuselage, you save more weight, which is more plus than what you would get out of a smooth, let's say, a smoother ducting inside. Mm-hmm. And you can also grind, because we are talking about foaming filaments, lightweight materials that we are printing. You can also grind this stuff very, very nicely.
That's true.
Right? And if you cut the parts correctly, you can always go with some grinding paper within the ducting and make it smoother again. Right?
Interesting.
And what you can also do is what I have also tried. You can use a lac, right? Just to spray it in, that you fill the smoother gaps and make it even more smooth, the ducting. Yeah.
But I agree with you there, Siggi. It is minimizing the risk. We want to have the big, let's say, big stuff that we want to get. That the most efficiency is about the opening, the volume, what you are pressing through, the EDF, what is efficiency like the JP. I just explained also the JP with the narrow gaps, lightweight. So weight is actually our enemy. And like RC, we need to do some concessions about the body, let's say. Yeah. And in this case, we decided to integrate the Pegasus ducting in through the fuselage, where you can save a lot of weight. I'm usually building a Pegasus ducting, which is separated. But this way, we sometimes this simplifying of the Pegasus, it works. It works.
Mhm.
And the sound is amazing as well.
That is
cool. But to find the correct ducting issue for especially a Pegasus, this is also a major task. How many have we printed of this one, right?
I told them already hundreds, Siggi.
We have printed hundreds to get the most efficiency out of a ducting like this.
Yeah.
Right. That's what I was going to ask, because I mean, that ducting design looks pretty intricate and designed. I'm sure you've had a whole bunch of different designs before you landed with that, right?
Oh my dear, we played so much with EDFs, we played so much with ESCs, we played so much with different ducting setups, and at the end of the day, this is actually the most efficient what you can, from my point of view, what I have tested, I can only say.
From our point of view, yeah.
Is the most efficient one you can get.
Yeah, 70% efficiency, what we have found.
70% is a good number, right? Yeah.
Wild.
And but these are still losses within the plane you have to deal with, right?
Right.
Yeah.
Because 30% loss of thrust is an issue. Yeah, you know that.
Absolutely.
So we did our bench test. We built our setup. We measure current. We measure power. We measure voltage. For example, we tested a lot of lipos. We measured voltage. How many voltage do you drop? Which batteries can hold the RPM? So higher voltage can hold the RPM. We try to play with high voltage lipos. And at the end of the day, we just adding one extra lipo, or we try to find the lipo that performs. In our case, we are not sponsored, but we are using Stefan Lipo Shop, for example, or Tattoo. They're delivering the C's, let's say. Yeah, so 65C. We need the power for a relaxing setup during hover. So your question was, what makes the Harrier difficult? So knowing the story about Siggi, about the 70% efficiency, finding the correct shape for an EDF. So it's actually also when you go for outbound transition, you're going to turn the nozzles, all of them, backwards to push the model forward. And what you actually want is to keep height. So you need RPM and pressure to keep it on height because it wants to accelerate. The KK2 board, so it's keeping the model leveled. So what it will do if you don't have an efficient setup or a weak motor or a weak lipo for whatever reason, it will drop out of the sky. So you can use a little bit of flaps.
So the 4 ducks, they're not pushing it forward, right? They're only doing vertical, and then there's another EDF that's doing forward flight.
So I got a nice setup over here, which is the Pegasus of our denier. So during vertical climb, the nozzles are positioned like so. Once you go for outbound, so when you reach a height of approximately like 30 meters, you're going to turn the nozzle like 25 degrees backwards.
Okay.
In this case, you need the model is accelerating, and at some point you want to gain more speed. It pushes to the back like this, and it starts accelerating like crazy. And can you imagine how strong the setup must be? Because we are using the front and the back EDF to give our pitch momentum by thrust differential between the front and the back engine. So also, can you imagine the model is starting to push like so? So you need a bigger EDF in the front because all the weight of the model is hanging to that nose, and you want to get fast. And also our additional EDS for stabilization, like a drone setup, Tony. So it's like a quad setup.
Right.
And these are also helping a little bit with what we called a Siggi T factor, right? So they are helping to accelerate climbing. Yeah.
So this one has individual EDFs on the wings, you said?
Yeah, I can show you.
That's wild.
It's a little bit difficult, but I will try.
So you're essentially powering 4. So you got to have enough battery to power 4 EDFs.
Yeah.
We have 2 batteries. We have 2 batteries on the plane.
Hold on. Let me remove the share screen so you can get a bigger. There we go.
There we go. Yeah. This is a.
Oh, you got one in the nose too.
Mm-hmm.
So you got the one driving the ducks. You got one in the nose, 2 in the wings, and then one in the back.
Yes, sir. And one big one in the middle. Yeah, indeed.
So there's 5 EDFs.
5. Yeah, correct.
Holy cow.
So you got, we got pitch momentum. You got your roll momentum. For going like the Z-axis, like so, we are actually turning the EDFs in the wing.
I'll get out of here. So those are controlled by a servo too?
Yes, sir. And the charge staff was a small one.
Oh, I see that. So I was also going to say.
And for vertical takeoff, we go to this position, and then we're going to rotate for forward.
Oh, so not only did you add EDFs to the wing, you needed to make them move. There you go.
Wow.
So yeah, you got your flaps, of course, and your gyros keeping it stable. So we use a big battery bay in the top, so we can put the batteries over there, and also one in the front with a magnet that we can put a smaller EDF. So all of this weight.
What size battery? And like what's the total milliamps you're putting in that?
4,500.
That's it?
Yeah.
6S?
8.
8S.
8S 65Gs. So this is good enough for 3-minute hover.
It's still not a lot. I would have thought it would have been a lot more than that.
So we can. So our sweet spot. So this is also the story. We call it Devil Circle. Huh, Siggi? We can talk hours about this topic. So friends, we got a lot of friends that say, "I just use a bigger EDF or use a bigger battery, right? Well, use higher Cs, more power, sure. But our sweet spot at this moment is 3.8 kilos. If you're going to add from 45 to 5,000, you will add approximately 120 grams, right? It's more weight. So the motor needs to run faster. Your current will gain exponentially. And then actually at the end, your flight time is even shorter.
Yeah.
So there is a sweet spot. And we are now discussing because this model has a fixed landing gear. And we want to have a retract landing gear to get rid of drag, right? And it looks cool, a retract landing gear, of course. So we are discussing now where to find a weight because we need to respect 3.8 kilos for this 105 millimeter EDF. So we're now looking for ESC. So our ESC is like 280 grams, 200 amps, 1214S. So if we can go back to maybe a 10S ESC, we are pulling now in hover 120, 130 amps. During vertical climb, we are pulling like 150, 155 amps. At voltage of 8S. So then we need to reduce. If we found a receive of an ESC, which is like 50 grams lightweight or maybe 100, then we are think, okay, we are 100 grams less. So maybe let's see where we can find retracts where are fitting this weight, you know. It's like balancing all the time. If you don't respect it and you will gain, if you go to 4 kilos, your amount of time will reduce. And then you got other problems to solve. So, but remember, it is an airplane. It needs to fly. So when you go to the corner, it would be nice if the wings are not folding upwards, you know, or somewhere in the field.
And
so it's really hard.
It's really hard.
Oh,
and then the next problem is when you change something, you might end up with an inefficient setup again. Yeah. Because the components do not fit together like that.
Yeah. So every time you change something, you might be affecting something else.
Yes,
it's something else. So it's like a domino effect, essentially.
Yes,
exactly.
For example, we are selling these files on RC JetPrint to support the project because we are buying a lot of EDFs and if you're going to change to another brand, with all due respect to Schubler 70, if they build, you got different blades, different pressure, you lose the efficiency again. And cooling, for example, we tried to use also aerodynamical students, to design us the most efficient setup. Remember, at the TU Eindhoven, and they managed to design almost 75 to almost 80% efficiency. That's great, but the motor was burning because
it's getting hot.
It's getting hot again.
So people are buying these STLs, right? So like right now, I could go online, I could go to RC JetPrint, and I can buy the Harrier STL. What's the feedback from? Are people getting this thing to hover? Like I own a store, so I know I get feedback from customers. Hey, this thing flies great. Hey, this thing doesn't fly great. Like, I can imagine that you're getting feedback from people who are buying.
The version that we have now online is a 90mm version, right?
Okay.
We never made this one to transition this model.
Okay.
We have to be honest as that.
Yeah.
And
but the
it
feedback
is
is
also
nice.
yeah, but you get a very, very perfect jet. Yeah. If you just put the nozzles backwards, you got a perfect, nice flying and very, very ambiguous jet there. It's really fast and it's fun to fly this jet, believe me.
And the sound is crazy.
And we also made this one to hover, right?
Okay.
We never transitioned this one, to be honest. And the STL files, what has to be clear to our customers, and this is what we are trying to tell the people, that they are buying into a project. They are not buying a complete finished product, let's say. Right? They are buying in a project. And it is also our aim that we grow together and make experience together with the customers that it works, right? And but until now, no one, honestly spoken, we got a lot of feedback that liked the plane, also flown the plane, no worries, but no one was able to make a transition with the plane.
Yeah.
Right. With the Harrier.
And with the Harrier, yeah. And then we decided, okay, let's make it a little bit easier. Let's make the 105mm version. This is the plane at Joel's place currently, and which has now done a perfectly, not the perfectly, but a transition, let's say, right?
We're still tuning this model. So about the feedback from customers. So what we also do, and this is my human thing, I guess, we are trying to visit all of them. And so we went to Ter Apel, we went to Germany, we went to Spain, even the guys who was really want to show, and I helped them to tune the KK2 board and made his first hover. Elderly people, with all due respect, who got the same passion to take off vertically in a garden, because I took off. We got bunch of video from feedback that people are trying to help their wife and taking off in the living room, make it dust free. So I have to say we are only human, and I'm really working during the night to help the people who are honestly asking questions. And I think, let's say 99.9% of the community giving us a positive feedback because they know the story, how hard it actually is. There are some people, they can complain a little bit because they're not super experienced with 3D printing or the complex setup, but we are telling this, and we try to make videos to try to explain how to set up the KK2 board, how to set up the printer, how to build everything slowly. So we try to help where we possibly can. Making complex manuals, the first thing when I see a manual, I throw it in the bin and I try to build my own airplane. But with extraction videos, I really try to learn. We did a video about how to tune the KK2 board. So how to recognize PID, where we started with the video with my wife who was filming with the iPhone to see it from the side and the front. If you see oscillations, a little bit reduce of P, how to set up properly the direction of the EDF. With the Donier, we made a really nice video. And even, sorry, Siggi, but even you were able to tune your KK2 and make your first hover, and you understand what I was explaining.
I'm just so surprised you're still using the KK2 at this point. It's a great board.
I'm sorry.
You are right. There's, from my point of view, I'm not, let's say, so addicted to the KK2, but it has one advantage, and this is you do not have to take your computer to the field.
Yes,
it's free.
You can take or open the door where the KK2 board is and do an adjustment there on the field and then go.
Yeah.
With all the other stuff, you would need to bring your computer, need to bring a cable there, and then
now you could do
everything on your computer.
Now you could do it through your phone.
That's perfect.
A lot of the stuff.
But what do you suggest these days? The iNav?
I'm going to get beat up on this because the iNav community is going to beat me up on this. I love iNav. iNav is a great program for fixed wing stuff. INAV's only been doing VTOL now probably for maybe 2 years, maybe a little bit longer. ArduPilot is where it's at. ArduPilot with a cube. See, so the reason I say that is, and the cube, you know, if you go back to the APM boards and all that, the cube now is kind of like the standard for people who want to build off of cool projects. It's just such a powerful flight controller.
And they are more compact also?
What'd you say?
This is also more compact to the basic Ardu platforms that we had in the past?
So the cube, I actually have one floating around here. I can show you it. The cube with the baseboard is not as small. Like, so the benefit, and this is the benefit of ArduPilot too, this is what I was going to say. A lot of the Maytech flight control boards now, you can use ArduPilot on them. Most of them. It's been like that for a bunch of years now. So I'll go grab a couple really quick in a second. The cube though with the board, it's not super small. So with your weight stuff, but the difference is there's a lot of manufacturers that make like development boards for the cube. Or custom boards basically for the cube. Like you could pretty much make your own custom board through JLPCB for the cube, for specific for your needs. And in ArduPilot, since ArduPilot has been doing VTOL, I don't know, 10 years. Like ArduPilot, that was the only way you could do VTOL back in the day was through ArduPilot KK2 basically. But if you really wanted to dial in, like ArduPilot was where VTOL was kind of at. So it's just built off of that. There's so many people who've built into that it's, you know, it's open source. I'm going to get beat up by all the INAV guys but I love INAV. So anything that isn't VTOL, I have INAV on. It's the standard for fixed wing. It really is. It's, you know, ArduPilot's great, but if I just want to quickly throw a plane together that has, you know, an airspeed sensor, a GPS, and it does, you know, loitering and all that stuff, I'm just going to put INAV on it because I'm done with INAV quickly. It's not as long as it is to program with ArduPilot. Yeah, give me a second. I'll show you an example of
So the cube is a derivative from the PixOC platform, right?
Yeah, I think so. Yeah.
Yeah. So
PixOC.
Yeah. So we did try the PixOC platform before. Yes.
It was flying to Timbuktu.
It was as soon as we figured out all the settings, because that was. You have so many settings, you know, figuring out what everything does. It's very difficult.
And again, Eric Maglio did a great job on that as well. He did a really great job.
But it did work really good, really good. We even loaded it with, indeed, like Anthony said, we did load it with ArduPilot. We tried many things with it. You can even modify it, your own flight profiles, and we did all that. I did all that. But in the end, just the value of a KK and the simplicity of a KK2 board is just unparalleled. Like it's very easy, it's very cheap,
lightweight,
and you don't have the fluff of 1,000 features. Many people, you know, it's nice that
GPS.
It's nice to have GPS and loiter mode.
Yeah, height.
No, we don't need that.
But most people, they just need the basics, and the basics is enough for them. And anything more than that, you can still do. You can take any flight platform and put it on, but then you do need to think about weight. You have to configure all of these things. The additional complexity of it just adds a lot of fluff to the development effort that we didn't need at the time. So for us, the KK2 board was perfect, but indeed for someone else, another platform like the Cube might be perfectly good.
It would be brilliant for us if someone would check it out with an Ardu or PixOC or INAV. It will work.
Experience for that.
It will work.
Almost back.
Maybe we could try again. I'm looking forward what Anthony's coming up with. Look at this shop, by the way. All those airplanes and cars.
He's got stuff everywhere.
And Jonathan, you got a cool lightning in the back as well. Awesome.
Nice.
Oh, the Aries. This is the Aries.
T-33.
So I haven't flown it in a while, but this is one of my little VTOL platforms. This was a plane that came out, I don't know, maybe 2 years ago. It's called the Femi Manta. So I bought the kit. This is a tilt rotor VTOL that the front motors tilt down.
Mm.
And this is running, this is actually running ArduPilot on this. It's got a little board in there. So that's the thing. ArduPilot opened up to regular little boards. So, and this is pretty cool. It's got a motor on the tail to stabilize the tail.
Mm.
Awesome.
So you know, like VTOL has become kind of like a popular thing now, where you can. I think this thing, when they came out with it, it was like $200. Like it was.
It's a tricopter setup there, right?
It's a yeah. So when you're in VTOL, it's a tricopter setup, and the front two motors will
turning.
Right. Mm-hmm. So they just tilt up and down, and that will give you your stabilization. And your back motor here will keep the tail stabilized. And when you're in forward flight, the tail shuts off. Not super efficient, because even though the motor will stop through ESC braking, you're dragging that prop around the back during forward flight. So it's not super duper efficient. But I have the two versions. I had a quad plane VTOL project that I was working on that I haven't finished yet. But this is a Maytech flight controller. You could put ArduPilot on this. So it's basically a 30 by 30 mount pattern, and you can put ArduPilot or iNav on this for VTOL.
And how many channels do you have there as output?
What'd you say?
How many channels you have as output?
This is an H743. This is how many outputs? Hold on, I'll just got to see it. I have no light here, real quick. It's got a lot of servo channels. So the way I had this set up, I believe it's been a while. I had this motor and ESC right here. This ESC on the back was going to the rear drive motor, because this is a quad plane setup. And then I had the other 4 ESCs hooked up to a PDB, a power distribution board, with the signal wires going straight to this flight controller. As far as servo inputs, it's got a lot. There's a lot of servo inputs on here, PWM inputs on here. It's got at least 10 channels. At least.
Oh, that's great.
1, 2, 3, 4. Yeah, it's got 10 channels. And then one of the other things that's great about iNav and all that is you can actually reassign some of the other. So if you need another signal pad, you can reassign one of the other signal pads in the CLI code. So Emar, I mean, you're the program guy. You'll figure this stuff out really quickly.
And the one question, you're only using one signal cable to each ESC, or what?
Yes. So automatically, and that's where you start to run into Joel's point with the PWM outputs. You can start running into some space issues, because if you have a plane that's got all kinds of servos driving flaps and landing gear, you're running out of channels, right? So right off the bat, I'm losing 5 channels, right? For propulsion. I have each individual ESC, right? Because you want to have them individually controlled, right? Because you want it to be stable like a quadcopter. And then you need your forward flight. So that's all individual PWM channels for the signal. So this is a brand new cube.
Yeah.
Oh, this looks heavy.
It's not so compared to this. Yes, you can see the size difference. Okay. Now you can run ArduPilot on it, and it'll do pretty much everything that you need to do with these. These are the way to go, and they're not super expensive. I mean, they've gone up in price because of everything in the world has gone up, right? But I think when I originally got this board, it was like $75. They're not like. They're not.
One question to get it started. Can you use a regular setup just to use and say this and this, and then do this and this, and do your leveling stuff and so on and so on?
Yeah, so you could put a basic VTOL program on it, basically, like a basic VTOL setup on it, and then tweak it from there. Which you're going to absolutely have to do that, like 1000%. But so this is the way they make a lot of companion computers with these. Like there's a lot more power built into this than this.
Yeah, so
This is a great platform. Listen, I'm not knocking even the Speedy Bee. I have one of those. You can do VTOL off of that too. Hold on.
I have a Speedy Bee too,
He's getting excited.
but just as controller, not as a stabilization platform.
Speedy Bee
Right.
But it's
Right.
compatible with something like this, the Speedy
So-
Bee that
So this is the
Marco
Speedy
has.
Bee. This is the Speedy Bee F405 wing.
Yeah.
This is a $50 flight controller. It'll do VTOL.
Yeah.
It'll do autopilot. It'll do everything.
Mhm.
Also, all
This-
autopilot. Okay.
It'll do iNav and autopilot. The Speedy Bee F405 wing. It's a great flight controller.
You can also have it as a stack, right?
Yeah, it's a stack. This is it. This is the 3 different parts to the stack. This
Yeah.
screws on top of this, and this is the top plate.
Yeah, you also stack them. Okay.
Yeah,
Oh,
it's
perfect.
just brand new in a box, so I'm not gonna take it all out.
Over the years,
but-
things have become a lot easier and better. So, like I mentioned, Anthony, before you left to get the cube, we have actually tried the Pixel before, which is the predecessor of the cube.
Right.
We've tried many platforms. A lot of them were great, especially these days. They're not like just an autopilot. They're like a mini computer that can run basically any kind of program. So you can run it with autopilot or your own code or whatever. So that now these days they're very powerful. But I remember the first time we got a Pixel. The Pixel was actually restricted to export from the United States to Europe. Yeah, there was the ITAR restrictions on it.
Okay.
So we actually had to get through a lot of loops in order to be able to get our hands on a Pixel, and then we of course we used it for a while. But like I said, still the KK2 is just cheap,
It's
very
the
affordable,
KK2
and it's accessible. And quite often we just want to slap something on there, go and fly, and we don't want to spend days figuring out the thousands of settings.
Exactly.
So the only benefit might be now with the stuff that you guys are pushing into and doing, you might get better flight characteristics and tuning out of the newer stuff. You get what I'm saying?
Yes.
So that's where the benefit might actually come in for you.
Mm-hmm.
Yeah, but we find that this is not really an issue at the moment. Like we're really fighting the devil's triangle, so the weight and the flight characteristics based on all of that. Flight computers are not a limiting factor in the development at the moment.
See, that's crazy to me. I would think that that's like one of the things that like, because it's controlling so much, you know what I mean? Like, hey, listen, the KK2, like FPV drones, everybody kind of owes their roots kind of to the KK2, right? It was the first real popular board that people could go out, buy, use, and so it's a great board. It really is. I'm not
The
knocking
difficulty only these days is I have to admit, honestly, they are getting old.
Yeah.
Right.
They're running on old drivers. So I'm using an older-ish Windows PC to flash it. So we're not using the original KK2 software, what's on the, how you call it, on what's already on it. But we flash it actually to OpenAero VTOL. There's a really nice community on RC groups. There was a guy who actually made it possible to rewrite the code to OpenAero VTOL, that you got two platforms, two free mixing platforms where you can switch between the both by switch. So you got a mixing setup where you use 4 or 5 EDFs and the servos. And in the second platform, based on time or curve, you can switch to a next platform which doesn't even use those EDFs, but only the control services, for example. So with fast iteration and fast programming, and I'm a mechanical engineer, not a software engineer. So I want to push something in what goes really fast. I can understand tuning. You are from the deep code.
Right.
So yeah, then we can go faster during time, because it's already taking 11 years. And
I get it.
And I hope to find, thanks to you, you've seen the Speedy Bee. Yeah, these are opportunities where we have to dive into. And now we have finally, after 7 years, trying with the Harrier, Siggi, we have finally managed to transition outbound all the stuff that we want, and also you get a nice flight time out of it. So now we are finally say, okay, this is our gate from this project, and now we can slowly move on to explore flight computers.
So
yeah, it's on the task list. It's on the task list.
Yeah,
I'm sure listen, I give you guys so much credit and respect because 11 years, 7 years, it's crazy what you guys have done. I mean, it's insane. Most people would have gave up, to be honest with you. I probably would have gave up after 5 years.
There were moments where
we crashed again.
Yeah, oh man, on the field, like flying for 20 seconds and then boom.
But look, this is also the plus with 3D printing, honestly spoken. When you crash, you have the files there. You can make your plane again, right? You can do iterations and then try again, right? And if you once buy a plane with 3D printing, you owe it for your complete life.
Right. You're on the side.
Personally, I think this is going to revolutionize how the RC airplanes, how it just works. Because the days where you go to a store and buy a kit, fly it a few times and then crash, and then
exactly
the effort of building again and then flying again, now you can just buy the designs, have a 3D printer, and just replace the parts that you've broken. You can
I'm with you. I'm in the middle. I don't know if you guys know this or not. It's kind of not like crazy news, but I teamed up with Kyle from Kyle's Designs, and we're going
build fast.
Yeah,
build fast.
I'm a big fan of that show. He's building fast.
Yeah, we're going to be offering kits off of some of his designs, like shipped to your door, printed already.
Yeah. And do you know what Anthony and Jonathan also? I also love what Jonathan is doing, building the big Aries. I really respect that, and I found it really beautiful to see and the sound of the turbine. But what I also try to do, and what I remember from your blog with Felix, what we both actually do, we invite schools. We try to inspire the next generation of builders, because it's getting less and less each and every time, and people want a kit with everything on it, out of the box, and a few dollars. Yeah. So and perhaps with 3D printing we can ignite that spark again, that people are trying to build. We have even simple throwing airplanes what we printed, and to see the smile on those kits, it's awesome.
I think that's part of the part that's missing from the hobby, to be honest with you.
Like the rookie. I need to put the rookie.
It's so I think that's part of the part that's missing from the hobby now, is it's so easy for people to get into the hobby, go buy a foam plane. They have SAFE or AS3X or whatever on their controller. They can get it up in the air. But then they truly, because they didn't build it, they didn't really have to work on it. They don't truly understand when something goes wrong, how to fix it. And I think that's part of what's missing from this generation of the hobby.
Look at this generation. These are really the five 6 years.
That is
right.
Awesome.
And this is already to start into 3D printing. Lightweight with foaming filaments printed, and just a capacitor plane, right?
By Vincent, our friend, huh? Yeah.
By Vincent. We made it together with Vincent.
You just throw it up.
That is awesome.
This is the beginning, right? This is our youth that is coming up here.
And the new filaments, they're coming out with new filaments. So like, I was looking the other day, they now have these the foaming TPUs.
Yeah,
you know,
crazy.
For what you guys are doing, maybe your ductwork on the inside, you guys might be able to do out of a foaming, very lightweight TPU, because you're only using it for ducting, and it might revolutionize how you guys are making what
we made a revolution in the last 4 months, to be honest. We released also a blog about printing with foaming ASA from ColorFab and Bamboo Lab. We made a major breakthrough, what we can say. So there's a big blog on the side of ColorFab, and we were managed because people are borrowing our STL files, and people want also Australia, maybe in America, maybe Atlanta is really warm and hot, let's say. And even when you bring your printed airplanes in your car, or whatever project, they melt. So people are spending money on our projects, and they don't want to be disappointed when they take out of the car. It's kind of free willy, let's say. So we are
melting away.
So we had an amazing breakthrough with the brand ColorFab. So we tuned, thanks to Mark Veenendaal, lightweight ASA.
Yep.
And the winds are like 20% even more lightweight prints.
Wow.
We print super slow. I'm sorry, it's only 35 millimeters a second print.
It's kind of a pain in the butt to print with. I tested it. I fought
it's
it. It's
easy now. I will share you the files after this podcast, and also the benefits about for sun, heat, UV.
Right.
It's gone, and we are printing really nice parts. And even if you can see, it's not even with warping. It's lightweight. It's only like a 10 grams this part. It feels stiff. It's not brittle.
It's like foam. It's really like foam.
You can print foam with this, and it's super cool. And also those big airplanes like the this is our latest project, guys. I want to show you guys. Wait.
Yeah, I tried the. I'm not done with it, but
do you have a printer? Do you have a printer?
Me?
Jonathan, how many do you have?
2.
2 printers?
Yeah.
I have a whole farm.
So
that's
cool.
That is awesome.
This is ASA lightweight running on the 70 millimeter EDF. The weight is 2.3 kilos, including retracts, running on 6S. You can push it to 7S with almost 4 kilos. You got the rocket ship over here. And it's flying super slow.
That's all lightweight ASA?
Yes, sir. And our weight, so it's 180 grams for each square decimeter wing load. It's super low, 180 grams on 2.3 kilos. So our stall speed is around 65 kilometers an hour for a starfighter.
And a small one. A
teeny one. Yeah, exactly.
That is awesome.
Yeah. So yeah, this is our latest project, by the way. So we're trying to experiment with ASA. Yeah.
That's cool.
So let me ask you a question. You were talking about the transitioning before.
Yeah.
What is harder to do? Is it transitioning from VTOL to forward flight, or is it coming in and transitioning back down?
The first.
Is it really? I would have thought it's the other way around.
Because when you go to vertical climb, the wings are not lifting. And also, when you have some headwind and you have to bend forward, the wind is pushing actually the model back downward, so your climbing speed is lower. This is one of the things. The outbound transition without lift is the most hardest part because you need to gain speed and you have to push. You have to push through the stall point. And then you have to transition the complete unit. The deflections are getting slower, and also the motors has to turn on. So this is exactly a point that is getting critical because you're going to switch off the motors, and then you don't want to fall out of the sky. So and once you are going, so we call this outbound transition. Okay. When you go for inbound transition, you can actually turn the throttle down. You can do your flaps out. You can glide and float the air model. You're going to turn on the transition because the wings are lifting the model. And then you go for inbound, and then you simply catch it like a drone, and you whoop.
Very cool. I was thinking in my head like
the video was there. My latest video. Maybe you can show it.
No, I know. I from like the setup and the building perspective of it, I in my head I'm thinking, like the stall speed of the plane, like what stops it from just flipping over and just crashing on the ground, because you're basically stopping it mid-flight and coming down, So yeah, that's crazy.
Just a 90-degree turn of the nozzles. That's it.
Wow. And I have to admit, Siggi, and I have to tell the truth, we have really good friends helping us. And for RC JetPrint, we met Ronald and also Marco. They are not scared flying these models. I'm building this for hours and hours, and I'm always gently, and then stop again, land, yay, and then step by step. And those guys are just, okay, hit the throttle, hit the switch, and just go. And I'm like,
you have to be brave doing this, exactly.
I'm sure. Wow.
Yeah. And we got a lot of feedback from the community who are flying the RC JetPrint F-35. And we're getting the feedback, we visit them, and we take over the settings, and we compare, and we learn from each other. This is the cool thing about the nice RC community.
Exactly.
The whole thing is great. I give you guys a lot of credit.
Yeah, absolutely, guys.
I've been following it for years, and I'm like, when you, like I said, I probably started following you 3 years in, and I'm like, this is crazy. Like this is the F-35 where it was twisted. I'm like, this is on a whole nother level. It really is. It's on a whole nother level. But
this is actually the next one.
Oh yeah.
We are working on. This is a single servo 3 BSM for our F-35B that is coming up.
so it's a single servo that controls.
It's a single servo, right? That is trying the complete 3 BSM.
Wow.
Look, gears.
That's insane.
Only one servo, we're turning 3 drones.
Right. So you went
Only
from
one
that whole
servo.
big thing that you had. Now it's more compact. It's lighter. That's crazy.
It's
This
lighter. And this part only weighs like 250 grams, right?
Wow.
250 grams. Problem is we are just looking for a programmable servo that is doing like more than 360 degrees.
Yeah.
We need a 1200 degree servo for this one, and this is not so easy to find in the market, right? It's not there, let's say. But this is actually the next point that will come up for the F-35.
So wild.
And this took us like 50 iterations to come to this point, right?
So the F-35, when people buy the STL, that one transitions now. I know you're saying with the Harrier, you're not.
That one transitions, but without this one, right?
Okay.
We are just turning a complete EDF currently in the
Okay.
transitioning, and this will be the next, let's say, stage, next
Next
level.
update that people can do.
But
Wow.
it's not easy for everyone, right? We have
No,
to
Yeah.
learn. And to tell you how hard it is, because it's not drone stable, you have to have experience with RC flying models, normal flying models. You have to have a little bit experience of flying with drones or with helicopters, and you have to combine these stuff. Because I had also made my mistake with this first transition, because at one point it's a drone, and another point you need to fly like an airplane. I was like, oh, where's the stick now for roll? Oh, this one, So you have to switch, and it makes it hard. So we are trying to learn. So we're traveling to our community, to airfields where people actually build it, and I will fly them first. And we have a couple of videos of those that we can share. And then we are learning, giving training, because this is what we can do. The feedback is we are making a lot of nice new friends and learning new communities. Wonderful people out there, really.
Well, it could go both ways too, though, right? So feedback necessarily may not be bad. You might have somebody else who is an aeronautical engineer who might help you guys and say, hey, did you think about this? I did this on mine and this is working. And it might give you some information. So it could go both ways. It could be a good thing as well.
We are open for everything, honestly.
Right.
And I also appreciate you guys, and also Jonathan. I follow him like years for now. What he is doing is very, very awesome. And the big planes, I would never be able to afford these, to be honest, but they are awesome. Also, the builds that you do is really, really nice.
Thank you.
I love you.
I think one of the successes of the YouTube channel is based on one of the personality traits of Joel. He is very enthusiastic, and that enthusiasm is contagious.
Right.
He has a way to attract people into this whole story, and they share their knowledge and they share their experience, and from that we learn, they learn. It's amazing.
Yeah,
he's a sales guy, you would say, right?
Come on.
But just look at the enthusiasm how Joel was talking in this podcast. I mean, it's complete.
So we're gonna start wrapping up. We've been on for almost an hour and 40 minutes ish. But before I leave, I just want to go through. I'm gonna do this real quick. Stop screen. I want to show everybody, Joel. We did RC jet print, so everybody has that. I'm gonna put all the links in the description for everybody. I'll put the links for RC jet print and VJM and everything, but also Joel has a pretty good following on Instagram as well. He's got 274,000 followers on Instagram, which is amazing.
Thank you so much.
they have the YouTube channel. And then also, let me do this again. They also have the Facebook page. And that one, they have some followers on that one as well. And then I'll share the VJM aircraft. So this is Joel's Facebook page. There you go.
Oh, that one. I have it in the living room still. My wife is allowing me to put this in the living room.
She's very understanding, as you said.
This is super
Very,
cool.
very. I don't know if my
Look
wife
at my
will let me fly
face.
something in the
Look at
living
my
room.
face. I'm shitting my pants over there. Look.
I don't think my wife would be as understanding to fly a VTOL jet in the living room. So
It's our leaf blower.
yeah, definitely keep her. Definitely keep her because she's definitely very understanding. Not too many wives would allow
she is.
that.
Yes, she is.
Yeah, for sure. How does that? Hey, honey, I'm going to fly this in the living room. Like, how does that go?
You even filmed it. And she asked me the question, is this a good idea? I said, yeah. Not.
Normally,
We'll
it's
clean
my
up all
wife
the dust for you while we fly it.
Normally, if my wife asks me like that, like, hey, is this a good idea? That's usually her saying, hey, this isn't a good idea. Like a subtle hint, don't do that. But yeah, thank you for coming on. I definitely would like to have you guys on again. We'll give it like 6 months or so, see where the progress is with the Harrier, and then we'll have you guys back on. It was an awesome time.
That was great.
And then
Sure.
just to all of our fans and everybody, this will be on YouTube right around Christmas. So happy holidays, everybody.
Happy holidays,
Thank you very
everybody.
much.
Yeah.
And all
So
the best.
thank you for coming on. I appreciate it.
Thank you for the
Thank you,
invitation, guys.
Emar, you're coming
See
back
you.
on too, buddy. You're going to come back on with Joel.
Yes.
Okay.
I'll happily be there. Yeah. Thank
All
you
right,
for having me.
guys. Have a
Bye-bye.
great one. Thank
Take
you,
care.
everybody. All right, bye,
Bye.
guys.